Last class we discussed about the frequency graph, distance graph, and velocity graph, and that three graphs are very important to determine what is the wind speed, because we know that there is a differences of wind from minimum, maximum, and very high speed. So in between that, the moderate value we are going to consider. So here you can see that VC, VD, and VT. So this is already discussed with all frequency graph, and this shaded portion will act as the actual load of a system. So from that we are going to divide the system of VF, VD, and VC. So today class we are discussing about selection, because it is very important to select the site for the windmill. So wherever you choose the place, that should be in a position to give a highest output. Means wind should be somewhat frequently available in the place, because as we have seen the graph, there was a variation in the peak. If you consider 12 months, so some peak months will be highest value and remaining all are moderated. So considering that, we have to take the average value of it. So here first one, the power available in the wind increases rapidly with the speed. Definitely we know that. Hence wind machines should be located preferably in areas where the winds are strong and present. So this is the first criteria. We have to determine which area we have a good range of wind available. Then the major contribution to the wind power available at a given site is actually made by winds with the speed above average. Means if you say like if you take the opinion, this says that wind is available. Okay, wind is available, fine. But when you're going for the prototype or installation, then you're going to check about the value higher than the required one, so that you have a authority that if you have a high speed, you can apply the brake and you can reduce the wind movement. If you have a moderated one, so then there is a chances of lagging where there is no production of power for a time being sense. So that's what the major contribution. When you're going for it, you have to see the place where you have a wind speed which is required, which should be more than the actual calculated or designed system. Then the most suitable sites for wind turbine would be found in areas where the annual average wind speeds are known to be moderately high or very high. So that's what, as the like continuation of a system, select a place where you have a good wind velocity and where it should be higher than the range which you are collecting, like calculating for the design of the rotor, blades and all, and preferably moderately high or high speed of wind available place will be located for a windmill installation. Then we'll go for the consideration. So main consideration for the site selection are, is first one is wind itself, because we know that power should be cube of a system, that is V cube. So then only we say that yes, this place is suitable. So here first with a fundamental requirements to the successful use of wind energy conventional sources obviously is an adequate. Okay, and the wind velocity is a critical parameter, because it is not in our hand to say, okay, now wind will come, now wind will go. We cannot suggest like that. So this is a natural phenomena, so that we say it is a critical parameter. Sometimes maybe it is very harsh, sometimes it is very calm enough. But as we have calculated with a problematic term, so your power should be always expected in terms of K into V to the power of 3. It is not 33, it is V to the power of 3. So always your power, when you say, it will be volume in terms of cube of a system. So it is evident because of the cubic dependency on the wind velocity that small increase in V mark affect the power wind. Because if you say this is like V is squaring or cubing, will going to definitely affect it, because it is directly proportional, it is not indirectly. Indirectly means if volume increases, or sorry, it is the velocity increases with the wind, then your power will start reduces. But here you have a direct proportionality, so you should be very careful enough with the wind velocity what we have. So if it is small changes, more than 3 means more than a cube, if it increases, there is a huge effect on the system. So you can see example, doubling the V, increasing the power by a factor of 8. So here your power will be get affected if the maximum changes happen with the term of wind velocity. And it is obviously desirable to select a site for WECS with high wind velocity. So whatever you do for a wind energy conventional sources, prefer the place where you have a high wind velocity. So next is How you're going to measure? Because simply I'm saying a word called wind velocity. And of course, we already know that the measuring device for a wind is anemometer. So we have to take the anemometer data. So again, in the anemometer, we know that magnitude wise, velocity wise, speed wise, all will be recorded, and that data analysis will be done, and data will be verified. Is it? So that all process we are going to do it in 3 to 4 steps. So let us think for that same condition, availability of anemometer data. So this is one of the important string actor. Okay, so while selecting the site, this anemometer data is very important. Then we'll see what exactly. The principal object is to measure the wind speed, which determines the WECS output power. Means based on the data, we can judge what will be the output of the windmill. Okay, but there are many practical difficulties with the instrumentation and measurement methods. Definitely, because as we say, you're going to take the annual data like day wise, year wise, hour wise, you're going to take it. So sometimes it show maximum, sometimes it show minimum. So going through that data is somewhat difficult to say, yes, this is the actual output from the windmill. So that's what they say. There are some of the difficulties where the measuring methods can affect, or the instrumentation data will be going to give confusion status for the output system. Then the anemometer height above ground, accuracy, linearity location, and the support tower, shadowing, and inaccurate reading. Because we already know how this anemometer should be placed in the region to determine the wind velocity. Of course, this is the vertical one, and cup-shaped wings are being used. So it is also look like a small fan. So that's what, depending upon the size, we know that 30 feet, 60 feet, height will be used. So that's what they're saying. You have to be very careful enough from ground level to high, which height you are keeping it. What is the accurate output we are getting it? How about the location? The how the tower has been supported means that anemometer, of course, it is having a wings like cup shapes. So that how it is supported, and they should not create a what inaccurate readings in the system, because you are completely depend on the data what you are getting from the anemometer. Then they form icing inertia of the rotor, whether it measures the horizontal velocity component or vertical, and the temperature effects are few of the many difficulty encountered. So based on the data, what we do, we start designing the system. So designing the system means here we know that there is a conversion of mechanical energy into your electrical energy. So this mechanical energy means there is a movement. How you going to do that? Do the machine, rotating machine, where I want to have a rotor. Means that rotor should be capable of carrying that speed. It should not run out of the speed, right? So it should not be less than the rotating condition, or it should not run out of the speed. So that's what you have to design it. And at the same time, they're specifying the temperature will affect the system, because temperature is high, temperature is low, definitely your wind will be affected from the system. So you have to consider the temperature effects which are happening in the wind system. Then anemometer data should be available over some time period at the precious spot where any proposed WSS is to be built, and that should be accomplished before a sitting decision in the made. Means it's like analyzing. It's not like one day you're going to observe and you say, yes, sir, this is the super place. So just take an example. You want to build a house. So you'll going to find the sites for the place, which place is suitable for me to construct a house. So you'll not take any one choice, like okay, you'll go to first site and you'll say yes. No, you'll go and see so many places, so many sites, and you'll see which are the benefits I have if I select this site, and what is the cost of the system, and in future how it will be developed. This area will going to develop, on what will be the economy of the system. All this minimum criteria we guys will going to choose. So similar way here also we have to select the, you have to take the proper data considering only one place, because you are, if we say after long verification, okay, this site is suitable for a windmill, again you have to go for considering the data availability. So that data availability you have to be taken care, and you have to design, because before installing this and all to be done, it is not like one day decision to made it, and they are all long running process. When you install a windmill, it will run for 25 to 30 years. So long run meters, clear. So that's what you should be very careful enough to do it. So next is availability of wind, VT curve, what the proposed time means velocity curve, because time plays a very important role. Is it how much time your wind is at high speed, wind is at low speed? So what time it is taking to move it off? So these are all things are very, very important because we already seen frequency curve, this VT curve and VF curve. So we'll see the important curve determines the maximum energy in the wind and hence the principal initially controlling factor in predicting the electrical output. Yes, we come to the part where we are going to have the electrical control. So from this, it will determine what is the wind energy, and from that, how much you are going to get the electrical energy. And from that, you are going to specify what will be the revenue return of your WCS machine. Because this renewable sources, why we are preferring, we say that after some years, that is expected to a payback period, if it is completed, we will be going to generate the revenue. And windmills, of course, all are government. Private sector means they are going to buy and they're going to sell it. That's it. But not in houses or residential purpose. We are going for this wind. So that's what you have to think about the revenue return of the WECS machines also. Then the VT curve also determines the reliability of the delivered WCS generator power. For if the VT curve goes to zero, then there will be no generated power during that time. Because we know that wind is a critical parameter. Whenever you have a good wind where it can generate a power, and that will act as a reliable power delivered from the WSS system. If there is no wind, there is no ability of your blade to rotate to give a mechanical energy for the conversion, then your output will be zero. From where you will come to know that VT curve will go to show. It's like a pulse rate. If it is going a sinusoidal waveform, you say you are alive, your health is something happening. But if going with a stand like a sleeping line, means completely horizontal, what it says, the person is not there. So similar way here also, if you get a variation, linearity increase in the system, you say yes, wind energy is producing. If not, if it comes to the standstill position, then you can say, okay, at that moment there is no output, there is no generation during that period. That can be easily determined from the VT curve. Next, wind structures at the proposed site. Yes. So these are all, as I said, designing of a system. You need to know what must be the blade length, what must be the width, what must be the vertical line, and tower, which you are going to keep it as a support. What must be that? Everything should be calculated. So you need to think about which design is suitable. As we are saying, wind blades and all, there are two types. Horizontal types are available, vertical types are available. So which one is better? If you heard the term called the Pelton wheel, Kelvin type, so there are varieties are available. Being a mechanical student of systems, if you study, you will understand. Okay, there are different kinds of blades are available for turbines. Okay, so here we'll see what structures will be considered at the proposed site. So ideal case for the WCS would be a site such that VT curve was a flat in the sense what it says. Your output is not there. But if it is somewhat variations, you can say there is a production. So that is more study. Wind that blows all the time, but a typical site is always less than the ideal. Means when you assume, because see, if I'm saying a theory, I'll just say, yes, this is there, that is this 100%, all those things I just say to it, the words. But reality, when it comes with, there are losses will be there are mechanical losses, frictional losses, rotational losses, so many things are there. And as we know that these sources are not in our control, then we have to think about the places, what is the variation, means approximation we can do it. So that's what they say, the typical output will be always less than the ideal calculation. Then wind, especially near the ground, is turbulence and gusty, because we know that the surface, smooth surface and rough surface are going to affect your wind. So that's what they're specifying. Wind will be especially near the ground in turbulence and gusty and changes rapidly in direction and in velocity. So the wind can affected with the area, which area you're selecting, hill station, seashore, or crowded area, or a rural area. So that will also affect your wind system. Okay, at the same time, surface, smooth surface, rough surface, that is also going to affect the system. Means uneven variations will happen and it can try to reduce the wind movement. Clear? Then this departure from homogeneous flow is collectively referred as the structure of the wind. Means I cannot say there is a continuous line, like I cannot draw parallel lines. Sir, every time I'm getting a natural output in a consistent way. I cannot say that because these are all the parameters are affecting the system, affecting the state. And this departure from homogeneous, this flow of collectivity, you can refer it as a structure of the wind system. And next we have altitude of the proposed site. Altitude, definitely altitude, latitude, angle of balancing the system, all are very important, because drift and draft and lifting the system is not so easy for wind. As I said, they will be turned together of weight, and if you want to rotate for one rotation, if you want to get it, then the speed must be so high enough. So that's what we have to think about, which is the altitude of the proposed site has been selected. So it affects the air density and as well as power in the wind. And see, this is first, density means how much mass we are getting it. It is like a force. See, if you are doing any work individually, definitely that will be finished. I'm not going to say that I'm not going to complete. But if instead of one person, if you do it in a group, if you do it in a team, it will be high efficient. Means within a less time, you guys are going to get the good output because you have a multiple ideas. That is a density. You can say number of people are contributing and you are getting a beautiful output. But one person, one thought, one idea, it will be executed but less time. So similarly here also, this proposed site where you have an attitude, that we're going to see in terms of density. The effect, it will affect the air density as well as it will going to reduce the power output. Okay, hence useful WCS electrical power output. Means indirectly you can see if your dense air density is affected, then wind velocity get affected. Wind velocity get affected means mechanical rotation will be not there properly, then your electrical output will also get affected. So that's what your attitude is also one of the important parameter for the proposed site. Then also, as you well know, the wind tends to have a higher velocities at higher altitudes. Means this is a natural phenomena. Lower altitude, you'll have a lower like velocity of a system, and higher altitude is a higher. This is like from the metallurgical people, you'll understand the strategy of specifying where we have a higher wind, where we have a lower wind. Then terrain and its aerodynamic. Of course, these terms are mechanical terms. Terrain and its aerodynamics means the dynamics means movement. As we say, it is not constant. It is increasing, taking a U shape and getting back. So that will be considered. Then if the WCS is to be placed near the top, but not on the top of two blunt hill facing the prevailing wind, then it may be possible to obtain a speed up of the wind velocity over what it would be otherwise. Means this is like placing the system. Of course, we want hill stations, we want the top portions, because if the altitude goes higher, you are going to achieve high velocity of wind, and that will going to give a high output of electrical output. But here you can see here, WCS is to be placed near the top. Of course, we want some top place, but not on the top of a too blunt hill. We want high than the natural ground level, but it should not be not a peak type or slant type or blunt type of hill which are facing the prevailing wind. Means they're opposite to the system, and you'll not have a proper balance, mechanical balance of the system also. And then it may be possible to be obtain a speed up of window velocity or what it would be otherwise. So you are placing, you are allocating, and the seeing the attitude is very important. Otherwise, you are going to get it the answer in the opposite way. Then the wind may not flow in horizontal, making it necessary to tip the rotor so that the aero turbines will be used. Means the movement. So we know that, as I say, if you are going in a rain, normally we carry umbrella. So if you want to get protected from the rain, I need to see which direction the rain is away, like coming up. So it can be on the center of the head. So you can hold it at the center, your umbrella. But let us assume you are getting from the front. So if that is the case, if you're keeping at the mid, then it is west. If you're keeping at the back, means you're taking it behind your head. Then because of the force, your umbrella will run off. But if you're planned very well, okay, I'm getting the rain front of my side, so I can hold the umbrella front so that you're avoiding, and it is with the same direction of force, means you're opposing the force in a proper way. But if the direction is supporting the system, then it will go off. It will take off the umbrella and you cannot catch it also. The same way here also, we need to think about the wind. how it should be aligned. Means your rotor rotation, if you want to get it, is it a horizontal case, it is a vertical case, or moving towards which direction, that is very important. So that's what they say. Aero turbines is always perpendicular to the actual wind flow. Means it has to cut the blade. So then only your turbines will start rotating. Means the direction is very important to gain something. So if your turbine has to rotate, means it has to hit perpendicular, not parallel. Parallel means it will just cross over the system. There is not even a single movement. But if it hit the system, then it is creating the force on your rotor. So rotor will start rotating the blade. Okay. Then local ecology. Local ecology, what exactly? If the surface is bare rock, it may mean lower hub heights and lower structure cost. And if trees or grass are present, all of which tend to destructure the wind, then the higher hub heights will be needed, resulting in larger system cost than the bars ground case. In here two cases. One is of small scale, another one is of a large scale. So small scale, of course, you can go for a bare rack. It may be mean lower hub heights, means your height, what you're creating with a vertical support. Hub is mid portion, right? So that height can be very less, and your cost will, the structural cost will be less enough. But if you're going for a huge investment, as the government is investing for generation, then we definitely prefer for the highest hubs. Means you can see if you are traveling in some highways, you can see the windmills, they're visible. But when you want to go near the windmills, it is almost 100 kilometers, 200 kilometers far away from your places. Okay, but it is away, it is seen, means you could have understand that was kept in a highest height. So that's what they higher the hub heights will be needed, resulting in your large system cost. Okay, that is the local ecology, small scale and large scale. And distance to road or railways. Definitely. Normally, this wind also, it is not in crowded area or forest area. We normally take it away from local. So distance will be a little bit higher, is it? So this is another favor the system engineer must consider for heavy machinery, structure, materials, blades, and other apparatus will have to be moved into any chosen WCS site. Means places. Of course, you could have seen if you have traveled the highway like Chitradurga, you could have seen the Chitradurga, of course, we have a wind power plant. So in that cases, the carrying the turbines, you could have seen the blades. I think Nelumangla highway also you could have seen that. Ring road. They used to carry the heavy vehicle will be carrying the blades and all. Means we need to have a proper transportation, proper road system where you can carry the huge blades. Okay, that is also one of the important task for an engineer to see to that. Okay, machines have to carry structures of blades, materials all should be carried to some particular place. So it is to be done properly with the specification. Okay, this route, yes, yes, I can have a proper transportation. I can carry all my machines with a proper vehicle. So this is also be one of the important parameter to know. Okay, what is the distance? Roads are available, rails are available. That has to be checked. Then next is nearness of the site to the load centers. Now this is obvious criterion, minimizes transmission line length and hence losses and cost. Means here once your generation is done, then distribution parameter takes place. How you're going to distribute without transmission? So that's what they say, load centers should be near to the system. So you will have going to minimize the losses. The nature of ground. So ground conditions should be such that foundation of what WCB are secured. Ground surface should be stable. Because see, if any normally Mangalore side and all in Karnataka, if any like floods are happened and all, you could have see the ground level. Like they normally people will used to construct their houses a little bit higher than the earth surface, and that is only individual houses like in their farmhouses. If heavy rain comes, there is like shattering of the soil will happen. So that is not favor for these kind of wind systems. That's what you have to choose the area where ground means the soil structure where it has a good stableness and where it will going to give a stable support for the WSS system. Then favorable land cost. Okay, they're coming to the last one. Cost, of course, it is the first point itself. You have to see to that the cost should be good enough. Means good enough means moderately, because you are investing more for your components also, and it will take much time for getting back that amount. The generation is not so high enough, but that's what your land cost should be favorable at this, along with other siting cost, entries into the total WSS system cost, because you need to have a number of members for build up that windmill, and some people are required for maintenance, and of course technicians, not local people are required, technicians are required. So we have other costs other than the installation and as well as site selection. So we have to consider all the parameters bound together to specify, okay, cost should be minimized. So that should also be favored to the place which you select to be minimized. Okay, these are all the important factors should be considered for the site selection. So this is the basic concept of wind energy. Of course, wind is one of the widest energy we are using it. So here construction wise, structure wise, selection wise, we should be careful enough. But compared to the solar, this is somewhat better with efficient output, because it will be run for day and night, but some period it will be off. There is no issues, but not like 8 hours, 10 hours. Okay. So considering this, we have problems on this system. Curves will be there, velocity curve, like a lifting curve, drafting, angle, RPM, all this type of calculations we are having it. I hope that can be start from next class. Okay. So we'll solve some of the problems with respect to wind energy in the future classes. Okay. So if I do, I think I need 1 or 2 classes for finishing of the problems, so that your internals will portion of fourth module will be get completed. Okay. Can you see to your activity box? Your quiz is started.